We are really lucky tonight. Dr. Micheline Matthews-Roth is a researcher at Harvard Medical School. I just picked her up there this afternoon, and we made such good time. We were here at 5:11, I think. And that's downtown Boston, you know. She researches on a lot of things. The things that we know about is stem cells. When the whole stem cell debate first started, Channel 2, which is PBS in Boston, had an extensive program on it, and I wouldn't say they were with us, but she was the expert on the program anyway. And we were very pleased because she says what's right and she says it like it is. So that was great. You may have questions. I mean, I'm sure you will. You may have a lot. We were talking about on the way out, and you know, a lot of the abortion questions now, people don't even ask you anymore because everybody knows. But the stem cells, if you're having a discussion with somebody, that's where they think they can get you. You mean you wouldn't cure whatever, or you mean that's the same as a baby, or, you know. So stem cells, it's beyond abortion. We did abortion pretty much for 3 weeks, and now we're moving on. But it's definitely the kind of thing that you're going to be challenged on. And we hope when you finish here that anybody who challenges you loses. So we're going to do this, and it's not a PowerPoint or anything, so you're going to have to listen carefully. And then William and Matt have this great thing. One of the things about stem cells, and you'll hear it even in the stem cells, is the misuse. I mean, you read an article in the paper, and it talks about stem cells. It never says embryonic adult, this, that, anything else. It just gives whatever impression it wants. And right through the whole pro-life movement, that sort of thing happens. So I think it's going to be really fun to see, you know, what's happening. So we really appreciate your being here. Are you okay with the light?
Oh, yeah.
There?
Yeah, I think
okay.
I'll be fine.
Well, thank you very much.
Okay, well, I'm glad to be here. And I am going to start talking about embryonic stem cells and also adult stem cells, because it's important to know about the two kinds of stem cells that we have. Excuse me. So what is a stem cell? A stem cell is a relatively unspecialized cell that when it divides can do two things. It can make another cell just like itself, or it can make any of a number of cells with more specialized functions. So that's a stem cell. For example, just one kind of stem cell in our blood can make new red blood cells or white blood cells, or other kinds depending on what the body needs. These cells are like the stem of a particular plant that spreads out in different directions as it grows. And then, well, let's see, some of this is appropriate to the Catholic Church, so I'm going to skip that. Now, people will say, well, you know, there are embryonic stem cells and there are adult stem cells. And the way you get embryonic stem cells is, unfortunately, you have to take a little new early person. As you learned, I believe, at the last lecture, a human life, and for that matter, any animal's life that reproduces by sexual reproduction, starts at the end of the process of fertilization. When the egg from the mommy reacts with the sperm from the daddy, the sperm goes into the egg, the chromosomes of egg and sperm line up, you know, the individual chromosomes line up with each other, because the egg has one kind of each of the chromosomes, the sperm has one kind, but our mature cells in our body have two kinds of each chromosome. So you have to have both, two kinds, to make an adult or a child, you know, a whole human being. So the process of fertilization allows the chromosomes from the egg and the sperm to unite and to line up together, and then this forms the zygote, the first cell of the new organism, be it a human or, as I say, any animal that reproduces by sexual reproduction. So that is when our lives began. Our lives began as a zygote, a one-celled organism. And then it started to divide and divide and divide, and eventually we got born. And of course, the process of growing to birth takes, as you know, about 9 months and goes through stages. I have here some material that I'm going to leave, and hopefully can photocopy it. Our photocopy machine wasn't working. And one sheet I'm going to leave with you is it compares, oh boy, I wonder if we should shut the door.
I was thinking that the only thing that aren't going to be too hot, but let's try it and see.
Yeah. Okay, that's all right. All right, so anyway, you learned how humans develop. In other words, we start growing from one cell, the zygote, which was formed by the union of egg and sperm. And the zygote starts to divide, and the first little thing is a morula, and then it forms what's called a blastocyst, and the blastocyst has an inner cell mass, a group of cells that sort of clump together. They grow and they clump together at one end of the blastocyst, and the rest of the blastocyst is one cell thick around the border of it, and it's the inner cell mass that becomes the embryo, us, and it keeps on growing, and then from the embryo you become a fetus, and then you're born. That's normal development. The next thing some people have decided to study embryonic stem cells. In other words, the blastocyst is made up of a bunch of cells, and each of them will help make the whole baby. So they figure, well, if we can take an embryonic stem cell, one of the blastocyst cells out, you can make a new person, quotes unquote, out of it. And this has been tried. It hasn't gotten very far in humans, to say the least, but they think they can do it, and they were thinking that, well, they could do that, and they could clone people that way. You can clone animals, but thank God you haven't been able to clone people yet, and I'm sure they won't, because it's just a little too complicated to do. But again, to do therapeutic cloning, you've got to start the life of a little individual and break the blastocyst open and take out some of the inner cell mass and use that to to let them grow and form the tissues and the organs and things that you want to use for transplantation. It's sort of hard. It hasn't really been achieved yet, but this was one of the theoretical things that people wanted to do to try and at one point to make people, and at a second point to make normal tissues and things for transplantation. There are, as I guess you can see, moral problems, because we know from science that the life of a human being starts with the zygote, and you've got to deliberately fertilize, have an egg cell from the mother fertilized by a daddy's sperm cell. You make this zygote, and then you dissect away its cells. And then if you want to make stem cells from an individual person, then you've got to artificially from a woman you would take isolate a blastocyst from her, and then you would try and get it to start to divide. You can do that artificially for a while, but then you'd have to take a sperm and have it fertilize the blastocyst, fertilize the zygote, and fertilize the blastocyst. No, what am I saying? Fertilize an egg cell and then get the growth to start that way. So it's pretty complicated and it's sort of crazy. As a result, that differentiate. It hasn't really been possible yet to do therapeutic or reproductive cloning. It was a big thing some years ago that they really wanted to do. Everybody was jumping on the idea to be able to clone humans and hopefully to clone people without genetic defects so that they would be totally normal. But excuse me, it's really, really very difficult. And at least on the human level, it has not yet been done with any degree of success. So I have a sneaky feeling that that's going to be pretty much out of the picture, for the future. But it's something that people should know about and realize that people have attempted it, but it just really is not going to work. However, stem cells themselves can be used for therapy, and that's the good thing about stem cells. If you have, defective muscles and things like that, you can isolate what we call adult stem cells, and you can. There are ways of isolating stem cells from actually most tissues of the body, and you can get them to grow, and with proper nutrients added to them, they would be able to form certain organs that you needed, or even cells like muscle cells, and that's one of the. And then you would grow artificially in tissue culture muscle fibers, and then you could transplant this, for instance, cardiac muscle fibers if you had a heart defect. That's one thing that people have tried. I don't know how successful they're getting to be, but that's one of the things that they were trying to do, was to grow artificial heart muscle cells that could be genetically identical to the person that they want to treat, because that's the only way that stem cells are going to work. And then this is the other thing with embryonic stem cells. They really are not going to achieve anything transplantation-wise, because people will reject them because they're not genetically equal to the person who's going to get them, because they're from somebody else's body. So it's sort of crazy to do anything to take little embryos and try and make stem cells out of them, because they're not going to be able to be used for anyone. So the best way to get effective work out of stem cells, effective use out of stem cells, is to stick to adult stem cells. And there are many techniques that are available to do that, and many cures are being able to be achieved by using adult stem cells. And let's see. This is, I think you probably want to have this, and I'm going to leave it with our chairperson, because you should have some knowledge about embryonic development. And this sheet of paper here compares the normal reproduction, making stem cells, and cloning. And it's a sort of a timeline of reproduction. And then also this is a set of documents that show the timeline of normal human prenatal development. And you guys should probably look at this, and it'll come in handy in your biology courses at school. And it does have good information on fetal development. And it really backs up the scientific fact that a human life starts at fertilization. Well, both of these things will do that too. So really the best thing about stem cells to remember is that adult stem cells are the important ones to look at. They have the most achievable stuff that they can do, and they're getting the most work nowadays. As I say, embryonic stem cells, although theoretically an embryonic stem cell can contribute to the development of every organ in the body, it's only going to work for the person from which embryo they come from. And you can't isolate embryonic stem cells from a little baby who died, or you know, the lady who had a miscarriage, an early miscarriage, from which you can find some few embryonic stem cells in it. Those will not work on anybody else, because they're going to be rejected, immunologically rejected, because they don't have the same genes and chromosomes, the same quality of the genes and chromosomes that the people that need the stem cell, that need to be the recipients of the stem cells, have. And so it's just like you can't transplant a kidney from Johnny Jones to Mary Smith unless Johnny and Mary happen to be twins or something like that. So the same thing is true for embryonic stem cells. They're really not easily applied to cures, whereas adult stem cells are. And that's why scientists are beginning to recognize that now, and that's why all the work is going on with adult stem cells. And so that is really, let's see. Well, this is not really terribly important, but the main thing about stem cells, again, is that you want to talk about to people, is that embryonic stem cells, to get them, it requires the killing of a growing human. Granted, a little one, but nonetheless a growing human being. And that's why a lot of people, a lot of religions are opposing it. And immunologically, they're not going to be workable for everyone, because the embryonic stem cells are going to have the immunologic characteristics of the mommy and the daddy who produced the embryonic stem cells. And that's it. And it's really only to either parent or a twin of the parents, or someone, you know, very, very closely related, not even a child, who can really profit from these cells, from organs made out of these cells. And although it sounds great, you know, to have found the cells that can make every organ in the body, practically it's just not usable. And that's the reason. It's because immunologically they will be rejected by anyone from whom they did not come. And that's why it makes much more sense to devote one's efforts to working with adult stem cells. Because, as I say, adult stem cells can be used for the person from which they come. And there are now techniques to transform adult stem cells into many other organs and things like that, and they're really very beneficial. And most doctors are, I think most researchers nowadays, are really beginning to work on them and to work with them, and hope that more people will be helped by them, and it's true. It's a very exciting field to be into right now. So, well, that's about all I wanted to say, because that's really all there is right now about stem cells to say. Embryonic stem cells cannot really be used, as I say. Yes, they're great because they can make every organ in the body, but they're only useful to people from, who are extremely closely related, and even that is risky. So the thing to do is to concentrate on what we call adult stem cells, and work with that, because they're more easily beneficial to the adults and also to anyone who are closely related to them. You have to have some immunological matches, obviously, to use my adult stem cells to make, say, a kidney or something for someone else. But to one of my kids, that would be probably easily doable. And they're easier to work with, and they seem to be very pliable, and most doctors are really now interested in them. So that's, I think, not much, but that's about all I have to say about embryonic stem cells. And as I say, adult stem cells are fantastically versatile, and it's excuse me, it's still a new field. I mean, things are still being developed as to transforming adult stem cells into tissues and things that you can use. But it's a going field, it's an exciting field, and it's a field that will be beneficial to many, many more people than working with embryonic stem cells. And in the meantime, you're not killing anybody, which is great. I mean, granted, a blastocyst is not a cute little baby, but a blastocyst is just as much of a human being as we are, and we shouldn't be killing them. And that's why people are opposed to abortion, and because life starts at fertilization, and they realize that. And indeed, although, well, it's thought that a fetus of 6 months development, 6 months of pregnancy, can feel pain. Before that, it's not clear. Certainly, there would be no pain sensation before 4 or 5 months of fetal development. But after that, yeah, the baby does feel pain. But at any rate, even if a fetus does not feel pain, he or she is still a growing human, and we really shouldn't be killing them. And as I say, in medicine, there are other ways now. You don't have to kill fetuses to get tissues, to make stem cells, or to do whatever else you want to do. And as far as pregnancy, as far as women are concerned, there are very, very few instances of the need to terminate a pregnancy for health reasons. Usually now, I'd say 99% of the time, a woman can be held through a pregnancy until the baby has a chance to live. And you can do a very quick cesarean section, get the baby out, and both mommy and baby are fine. So it's just that we have to remember that where a life begins. And as moral people, we really ought to stress our point of view to say, hey, we got to do this. We can't go around willy-nilly killing people, even little teeny tiny ones, even little embryos. They deserve a chance to live if they've been made. There are enough ways of preventing pregnancy in people who don't want to get pregnant, and people should act responsibly enough to use whatever methods they feel that in conscience they can use. And there are, granted, some religions, including mine, do not accept certain methods of artificial contraception, but there are methods for contraception, quotes unquote, that don't involve drugs or uh, apparatus or whatever you want to call it. There are legitimate ways of putting off pregnancy. So there is no reason why people have to resort to an abortion to terminate a pregnancy, to kill a baby, because it's inconvenient for the family to have a child now, or the woman doesn't want to have a child, or whatever. And as I say, for the health of the woman, there are ways that you can do a doctor can do a very quick abortion. If she goes into heart failure or something like that, they can put her on the table, get the baby, everybody survives, and very quickly and with no really serious effects.
Before we get to questions, I want to say
Yes.
you said abortion by mistake. You meant to say cesarean section just now.
Did I? Oh dear, yeah.
It just, that's what we, yeah. So I think maybe people will have questions, and this is a good time to start.
Okay.
Yes. What do you know about induced pluripotent stem cells? I think it's a recent field that they just started in
IPS,
Japan,
yeah.
right?
Yeah, they are not, I believe, made from embryos.
Yeah, no, I think what they do is they take regular cells and then
Yep.
force it to start replicating.
Those are fantastic. And I think that's one way of, quotes, making organs that will be needed by an adult, and making them, in a safe and immunologically competent way, to make artificial to make, quotes, new kidneys and things like that. No, they're great. IPSs are fantastic. And I believe there are no moral contraindications to their use. Yep. Yes.
Where do you get adult stem cells?
Skin, blood. Many organs apparently have some. I think you can biopsy like kidneys or something. And I believe livers also. Probably other glands.
And so they're cells within certain organs in adult
Yeah, and you
people.
grow them
And
in tissue culture in the presence of certain growth factors, and this will allow them to sort of, quotes, revert to an embryonic stem cell type of lineage, and then you can force them to go one way or the other to develop what you need. And that's the idea behind IPS, which is fantastic.
I want to say something about that, though, because when we say adult stem cells, what we really mean is non-embryonic.
That's right. That's right.
So the embryonic stem cells would be, a little embryo would be killed to get those cells.
Yep.
Once you get, say, to a fetus, and maybe the mother has a miscarriage, and if there are any cells available, those are adult stem cells,
Yep.
even though they're from a fetus, because they're not embryonic. So
That's good.
really, instead of adult, we should say non-embryonic. The stem cells from cord blood, which is getting to be a huge thing in Massachusetts, thank goodness, those are non-embryonic, so those are adults, even though they're from the brand new baby.
Right.
The other thing I want to say on the embryonic stem cells, not only does it kill the baby, but they reproduce differently from the kind of stem cells you're talking about. And most stem cells make one cell that's just like themselves and another cell that is somewhat different. So otherwise, we wouldn't keep, we would die after whatever amount of time. So that everything we have is making new stem cells. The embryonic stem cell doesn't do that. It doesn't make one the same and one different. I believe it makes two different. So there's no control. If you start with a hard stem cell, unless you regress it, you stay with a hard stem cell. With the embryonic stem cell, so what happens is, so far, and unfortunately this is happening, they're finding, even in the ones they've created, is that you get this uncontrolled growth. Well, an uncontrolled growth of cells in the body is
Tumor.
cancer, a tumor, exactly. And so that's part of the reason there's been no success,
That's
because
right.
the people have died from the supposed cure.
Yep.
And unfortunately, the regression now, and I think this is awful because I think it sounds a wonderful thing to me, they're beginning to say that possibly the tumor problems haven't been completely wiped out. So, but that term adult stem cells, I just had to jump in when you said that, because you really have to think non-embryonic. And if you're talking to people, it's so exciting. What is it, 90-something diseases now? You can go online and it's always there. Are being cured by adult stem cells. But if you're talking to somebody, it's really good to define it right off the bat. When we say adult, we mean non-embryonic, because otherwise you think only from people who are over 21 and who wants their old cells, and, kind of thing. So I think it's very, very important, especially, you couldn't do it in Massachusetts like 5 or 6 years ago, but you now can save the cord blood. And some people bank it and pay, like a rental fee that, have it banked. And the idea being, if their child, that one or others, had a problem, this might help. What I think is better is a lot of people donate it, because there's not very much cord blood. And so after age about 6 or 7, there isn't enough to cure that particular child. But if you donate, then down the road, if you need something, maybe other people will have donated and they can, put more together. But the potential is just tremendous, and it doesn't hurt anybody, it's in the umbilical cord, which would be thrown away, and I think they kind of milk it out, and yet it just has all this potential. So the whole thing, it's going to be more and more in common talk among people and everything. So it really is very, very important to know.
Yes, absolutely. Yes.
So, is it fine if a mother has miscarried a baby, say, to take cells from that baby?
Probably. Although I don't know, because it depends on why the miscarriage occurred. And it's hard to know whether, for instance, if the baby died in miscarriage because it, say, didn't have a heart or something like that, don't know whether cardiac cells are missing in every, the cardiac genes, rather, to make the heart, or to make heart tissue would be missing in every cell of the miscarriage or what, I don't know. So for serious miscarriages, it might probably be better not to, or very early miscarriages. But some people will have problems with, like, the umbilical cord contracting or something like that, or the placenta sort of detaching itself from the uterus, and this causes a miscarriage. That's probably okay, but would be hard. I would think that sort of decision would be better made by an obstetrician, who would know the actual reason why the baby miscarried.
Many times the baby dies, and it's quite a while before the baby is delivered.
Yeah,
and so you're not going to have good quality cells. But if something happened, like if the mother was in an accident or something, and the baby had been healthy before, so there's a whole bunch of reasons why someone might have a miscarriage. And then I think it would be the same as organ transplant. A family would decide if the baby cells were appropriate, was it something they wanted to do or not? Just like if someone dies and does the family donate the kidneys or something?
That's all part of it too.
One source that I don't really know much about is the amniotic fluid. So what is that? And
well, the amniotic fluid is the fluid that's in the amniotic sac, which is lining the uterus during pregnancy. And that does have stem cells along its membrane, along its periphery. And some of those are sort of secreted into the liquid, into the amniotic fluid. And some people can harvest those during labor, catch some of the amniotic fluid when the mother, breaks her membrane. And they collect those cells. And they seem to have some characteristic of embryonic stem cells, in that they can make organs and things, or tissues. But I don't think all that much work has been done on them, or at least I haven't been following it, let's put it that way. But theoretically, those cells can also work.
So in theory, it could be like an alternative to embryonic cells?
Yeah, right.
Okay.
and at least a non-killing alternative to embryonic stem cells.
Right, so those cells and the cells of a miscarried baby would be non-embryonic stem cells.
That's correct, yeah.
Although, you're right, the terminology is very confusing because it's an embryo, but those cells are not embryonic stem cells.
Right.
Well, it's not an embryo, but then it would be a fetus, or,
Yeah.
you know.
Right, I think there's a small window you can get the embryonic stem cells, like a few weeks, I think.
Right.
I would wonder even that long.
Okay, like a week then.
Yeah,
But, yeah.
or a couple of days or something like that. So,
We have about 2 more minutes if anybody has any more. And I'm afraid you'll go home and then think of your questions.
well, bring them in next week, and Mary can always contact me, Pat can always contact me
Yeah.
if anyone has a question.
I have a question. So do most embryonic stem cells, do they come from embryos created in a lab? Obviously, they would it would have to.
I would presume so, the ones that people do research on, I would think so. Because again, if a woman has a period that's a couple of days late or something like that, you know, she'd have to be compulsively charting her periods, and then, oops, my period came a week late. Gee, was I really pregnant? You know, it would be hard to know whether there were any embryonic stem cells in that.
But you know, I think that's another thing that's important to remember, because what people say is, oh, well, these babies, they don't say babies, these embryos were created by in vitro fertilization and the parents don't want them. So this way they would be going to some good use. Well, I mean, the point is, in the first place, they shouldn't have been created. And secondly, once they are created, they're human beings.
Right.
But that's always the argument. Well, you know, nobody wants them anyway, they could be doing some good, and we know they're not doing good. The people who are experimenting are having a fine time for themselves, like the kids in the sandbox, you know, but it's not accomplishing anything therapeutically for anybody who's sick or anything. But even if it were, again, as the doctor said so well, this is a human being, but that's where they tend to come from. And I was just reading that the average is at least 8 babies not used for every baby who's implanted in vitro. And a lot of those babies don't make it. So it's a lot more than 8 for any in vitro baby who's born.
Yeah.
So they're saying, well, we have all just an article about all the leftovers who are discarded every year in the United Kingdom. So that's where they would have to come from. And
Oh, yeah, well, just on top of that, not only is in vitro fertilization morally wrong to the Catholic Church, but it's also wrong scientifically, because the strongest sperm is what makes it to the egg and penetrates and fertilizes. When they just take sperm and put it on eggs and make it, that they're creating a bunch of babies who normally wouldn't have come into existence, because maybe they wouldn't have the same chances of surviving outside of the womb or even in the womb.
Yeah.
So it goes against everything.
That's a good point. Yeah.
I'm glad you came, because you know, the studies show that children born from in vitro fertilization do have more physical and stuff problems, and that's a really good explanation for a lot of them. You know, because they've been trying to sort of say, well, why? They know it happens, but why? And that's a very good explanation. It's really good.
Yep.
Well,
Any other questions?
thank you very much. Well, it's up to you. You don't want to sit here because of not being able to see the screen.
Oh, yeah.
But it
Oh, I
looks
see what
cool
you're saying. Yeah, I can
by
see
the
what you're
window.
saying.
I don't know. We appreciate both of you very much.
All right, well, first I'm just going to hand out some flyers with different, we got something from Narrow Pro-Choice, Massachusetts, so you can see some of the language that they use in there. take a sheet and pass it around, and then this is from the ACLU website if you want to see some of what they're saying. Take one and pass it around. So.
And you know, it's almost more important to read some of this stuff because we can talk to ourselves forever. And unless we can handle what these people say, we're not going to be effective when we get out there.